Okay, good day, class. So today we're going to be looking at the switch case, the loop, and also the nested loop. Now let's look at switch case. Now switch case is used when you have many discrete values to check. So the syntax here, we have the switch, we have the expression, and then we have the case values will break, the case value 2 will break, and then the default. Now let's look at a good example here. We're trying to get day 3, right? So we're trying to get if day 3 is Monday, Tuesday, or Wednesday. Now it's very simple to use a decision to actually do this, but you can it's also trying to make a decision also. So we have the switch, which is we have a variable called day, which is on the tree. So we're trying to find out the case where this guy belongs to, where this variable tree actually belongs to. So the case 1 we say print Monday, then case 2 print Tuesday, case 3 print Wednesday, and then break, then case 4 another day. Right, so let's try to do a simple example here. So this will be example 8, 5, example 8. Let's see. So we have the include stdio hello. Now int main. Now let's say we have a variable called this day and it's holding 4. It's holding 4. Now we have switch day. Alright. Sorry, I think I'm using switch day. We have case 1. So case 1, what happens? So if this is case 1, so printf so let's say this let's use let me use day, then the number of the day here, which is specified, the days is Monday. Then let me just pass to the next line here. Then we use day. Okay. So let's do another one. So case 2, then we have to break this. If not, even if it prints out this as the answer, it will go to the next answer to print out the default if we don't put a break. So let's do another one. Now case 2. Okay, this is Tuesday. Case 3. This is Wednesday. Then case 4. This is Thursday. Right, then let's use default. Right, then let's use it is another day. Let's remove this. Okay, so the order C normally will return 0. So let's try to run this. So if we run this, what prints out here, it will print out case 4 because this is equal to 4. So let's run this. So we have GCC, then example 8.c, then the output example 8.exe, example 8.exe. So day 4 is Thursday. So assuming we have something like day 5 here, let's recompile this and run this. It is another day because there is no case for 5. Right, because there's no case for 5, that's why I print out the default here. It is another day. So that is how the switch case works. So depending on what I want to do with it. So assuming that I want it to be dynamic, I want it to be dynamic, so I'll just be clicking on this and print of. So print of. Please enter enter the days, the day, right? Please enter the day. So remember, this is int day, so there's nothing specified here. It's then please enter the day. So I want the user to print the day here. So this percentage d and day. Right. So when the user enter the day, what happens? So when the user enter the day, then depends on, let's compare this. So if I run this now, please enter the day. And so if I put 2, day 2 is Tuesday. So let me just make this, sorry to space. Yeah, let's run this again. Okay, please enter the day. Let's put day 4. Now day 4 is Thursday. So let's run again. Let's put day 1. Day 1 is Monday. So let's put day 5. Day 5 is another day. So assuming day 5 is here, so we're gonna print day 5, which is Friday, day 6 Saturday, day 7 Sunday. Now you can see how it works, right? So we have dynamically allowed the user to enter the day, right? So that is how the switch case works. So let's look at the loop. Now for the loop, let's start with the while loop. Now the while loop repeats while condition is true. So when we're writing the pseudocode in our module 1, right, so I explain how the computer processes the while loop, so we're going to be seeing it here. Now let's look at example 9. Example 9.c. Right? Now let's include stdio the int main. Now let's look at example 1. So let's look at the slide. So we want to like make a simple loop, right? We want to loop through from I less than equal to 5, right? So we want to loop to just a simple one so that you can understand better. Now I want to loop from 1 to 5, right? How do I do that? Let's say int I is equal, or let me say from 0 to 5, right? Let's say int I is equal to 0. Then let's say the length int n is equal to 5, right? So this is an input, this is an input. Then we'll say while it's actually repeated the decision. So while I is less than 5, while I is less than 5, so what happens? While I is less than 5, so on the print, I want to print I. Right? I want to print I and then increment I plus plus. I by 1, or we can do this I plus plus, or you can do this I equal to I plus 1. Alright? Then I think that's it. So let's explain this. Now let me use the comment to explain this. So we have int I equal to 0 and we have int n equal to 5. Now why I is less than 5? So our I in the initial phase was 0, right? So it means is 0 less than 5. Now this will keep on repeating until I becomes until this first statement is false. As long as this first statement is true, that is why I keep on repeating this, until this is false. Now because 0 is less than 5, so what happens? It will print I. So our I is 0, so it will print 0, and then it will increment I. So our I now becomes what? So increment I. Our I becomes what? Our I becomes I equal to 0 plus 1, which will give you 1. Then it comes again, because it's a loop, it comes again. So let me just repeat this. So when it comes again here, our I becomes 1. Our I is now 1 because I is 1 here. Yeah. So is 1 less than 5? 1 is not less than 5. Sorry, 1 is less than 5. This is true. Then it will print I. Our I is now 1. So we need to increment I again. So our I becomes what? 1 plus 1, which will give you what? 2. So it does the same thing. Is 2 less than 5? Now 2 is less than 5, so it will print 2. As we increment I, so our I becomes what? 2 plus 1, which will give you what? 3. So it comes again here. Is 3. Is 3 less than 5? 3 is less than 5, so it will print 3. So increment I, our I becomes what? 3 plus 1. And this will give you what? 4. And it comes again here, our I is now 4. So is 4 less than 5? So 4 is less than 5, which will print 4. And increment I, so our I becomes what? 4 plus 1, 4 plus 1, which should give you what? 5. Then it comes again here, is 5 less than 5? And 5 is not less than 5, so it will, this, since 5 is not less than 5, it will not go to the next line, rather it will terminate because this is false. So since 5 is not 5 is not less than 5, the while loop terminates or stops. But assuming that this while I is less than or equal to 5 is like this, now then you say this. Now 5 is not less than 5, but 5 is equal to 5. Now these parts will run, and this will print what? And this will print 5, right? And this will print 5, and then it will increment I. It will increment I, so our I becomes I equal to 5 plus 1, which will give you 6. Then it comes again here, so is 6 less than 5, less than or equal to 5? Now 6 is not less than 5 and 6 is not equal to 5, so this is where the while loop stops, because 6 is not less than 5 or equal to 5. Fine, so these are programmed right now. So this while loop will print out 0, 1, 2, 3, 4, 5. So let's try and see what happens, right? And this is how the computer processes this instruction here. So let me just put return 0. Although even if I didn't put return 0 by default, it will still do this, right? Because this is more than C. Okay, now let's run this again. So this is example 9. So I will compile this. Okay, I've not actually compiled before. So gcc 9.c-o example 9.exe. So example 9.exe, you can see, right? So it prints out 0, 1, 2, 3, 4, 5, right? So that is how it works. So but if I actually want to print the next line, so let's see this, right? Okay, because I want to print the next line, so as you can see 0, 1, 2, 3, 4, 5. Now if this one is out, it will print out only 0, 1, 2, 3, 4, and then it will remove this, right? So let's run this and see again. 0, 1, 2, 3, 4. So you have to be very careful. So when you give an instruction like this, make sure you try to solve it like this, and you will never get a wrong answer. So let's leave it like this as example 9. Okay, now let's look at another example. Now we want to try to get the even number between 0 and 5. Like the even number is supposed to be, but if I ask you guys as a human, so you're supposed to know that the even numbers are 0, 2, and 4. Now let's try to do something. Then we'll do some random examples, some random exercises here. Then we'll try to solve it, and we'll see how computer processes the instructions. So let's do another one. This is example 10.c. So let me just copy what is example 9 so it will be faster. We'll copy example 9, then this is example 10, paste here. Now I have my variable which is I 0 and variable n equals to 5. So why I is less than or equal to 5, then I will have a decision here because I'm trying to get an even number, right? So I have a decision. So the decision is if I modulus 2 is equal to 0. So what happens, right? If it is equal to 0, so print this is an even number. Then I'll put the I. Then that particular I is an even number. right? So then I will increment I, which is I plus 1, this. Okay, so I've already done this, right? So it means that let's solve this together. So what this means that our I is 0 and our n is 5, right? So if 0, okay, is 0 less than 5, now 0 is less than, okay, 0 is less than or equal to 5, okay, is 0 less than or equal to 5, right? Now 0 is actually less than 5, so what happens, you come to this next line here and say our I is our I is 0, is I modulus 2 equal to 0. Now that is I, that is our I is 0, so 0 modulus 2, so 0 modulus 2 is actually 0. So is 0 equal to 0? Yes. Now since 0 is equal to 0, so this will print what? This will print I, so this will print 0, and then it goes out of this decision here and print I plus 1. So into increment I, so our I becomes what? 0 plus 1, which will give you 1. Alright, then it repeats again. Remember, this will keep on repeating until this is false. That is when the while loop stops, right? So is 1 less than or equal to 5? Now 1 is actually less than or equal to 5, right? Now let's check this. Then is 1 modulus 2 equal to 0? Now 1 modulus 2, the answer to 1 modulus 2 is 1. So 1 is not actually equal to 0, so nothing happens here, right? So nothing happens, it prints out nothing because there is no else here. If there is a else here, that is only when you print out something. But since there is no else, it prints out nothing, right? So it's a print out nothing. So our I becomes 1 plus 1, which will give you 2. So it comes again here. Our I is not 2, so it's 2 less than 5, less than or equal to 5. Now 2 is actually less than 5. Then here becomes 2 more 2, 2 modulus 2. Now 2 modulus 2, the remainder is 0, right? So is 0 equal to 0? Yes. So it comes here and print 2. It comes here and print 2, and then increment I, which our I now is now 2 plus 1, which will give you a 3. So it does the same thing here, is 3 less than or equal to 5. 3 is actually less than 5. So now 3 becomes the next line, 3 more 2. Now 3 more 2 is 1. So is 1 equal to 0? No, 1 is not equal to 0. So this will print no. And it will increment I, and I becomes 3 plus 1, which is 4. Now it comes again here, is 4 less than or equal to 5. Now 4 is less than 5. So we give the next line becomes 4 more 2. Now 4 more 2 we give you 0. So is 0 equal to 0? Yes. So this will print 4. And it will increment this, which is 4 plus 1, which will give you 5. Now it comes again here, is 5 less than or equal to 5. Now 5 is not less than 5, but 5 is equal to 5. So this is true. So you come here and do 5 more 2. Now 5 more 2 is 1. So is 1 is not actually equal to 0. So it prints nothing. And it will increment I again, and I becomes 5 plus 1, which is 6. Now it comes again here. So is 6 less than or equal to 5? 6 is not less than 5, and 6 is not equal to 5. So the while loop stops. The while loop stops or terminates. Alright. So that is how it works. So that is how computer processes the instruction, and this will print out 0, 2, and 4. So if you're running this, it will give you a exact answer like this. So let's run this. So we have the GCC example 10. Let's see the output. Then example 10.exe. Then we have this example 10.exe. So 0 is an even number, 0 is an even number, 2 is an even number, and 4 is an even number. So let's try to make them to be the next line. So to make them be in the next line, we're going to do this. So let's recompile this. 0 is an even number, 2 is an even number, and 4 is an even number. Now you can see how it works, right? So it's very, very simple, very easy. So let's try to solve another example, but this time around, I'm just writing around the instructions and see how computer will process that instruction, right? So let's try to do this. Example, or let's leave that for now because of time. But if you understand this, you can be able to solve any kind of while loop, right? You can solve any kind of while loop here, right? If you understand something like this. Now let's try to solve another problem. Let's look at while loop, and now let's look at the for loop, right? Before we will look at for loop, we need to still understand the do while loop. Although the do while loop is here, which is supposed to be after the the while loop, right? So you need to understand the difference between the while loop and the do while loop. Now let's look at this. So I want to do this again, but I want to be using do while loop to do it, right? I will copy this. I'll make this example 11.c. So let's put this here. Now let me use the do while loop to actually do this. So we have the do, right? So the do, now this will print out. This will actually print out the I, right? This will print out the I, then this will increment I equal to I plus 1, or we can say I plus plus, right? Then while this, why this is this, now if this is this, so this will out. Okay, so do this, right? Do this, then let's put the if here, right? So let's try to see how this works. So I'll compile this. This is example 11, right? So example 11, so this will be 11, and this one here will be 11. So 11.exe. Okay, now this is what it showed me. 0 is an even number, 0 is an even number, 1 is an even number, 2 is an even number, 3 is an even number, 3 is an even number, 4 is actually not doing the right thing, right? So we have the do, we have the printf, which is this, right? Then what it does is the first thing it needs to do to execute this is to print I, which I is equal to 0. Now do, now if this is this, so our I is 0, right? So now let's work on this instruction and let's see how it works. So I will try to correct it, and then we'll do other things. Now we have to print this. So what first thing we print out is to print out I, which our I is 0, right? Which our I is 0. So to print out I, 0 is an even number. To print 0 is an even number. Now it comes this next line here is 0 modulo 2. Now 0 modulo 2 is to print out, to come here and still print, and still print 0 is an even number. Then to increment I, right? So to increment I, there's an even number, so to increment I, so our I becomes what? Our I becomes 0 plus 1, which is 1. Then comes to the while loop. While 1 is less than 5. Now, while 1 is less than 5, print this. Now, it's going to still print this, right? Because it's going to print 1 is an even number. Because while 1 is less than 5, 1 is actually less than 5. We're going to print this, so let's remove this out. So instead of printing this, right? Instead of printing this, it comes down to this place here, right? So while 1 is less than 5, so it means it comes to the while loop. Now, is 1 less than 5? So this is true. Now it goes again to the do. Now see, this is true, a check. So is 1 modulo 2 equal to 0. Now 1 mod 2 is actually 1, and 1 is not equal to 0, so nothing happens, so it increments I, and now I becomes what? 2, right? Now I becomes 2. Now it will come to this while loop here and said is 2 less than, it comes to the while loop again, say is 2 less than 5 less than or equal to 5. So this is less than or equal to 5, and this is 2 less than or equal to 5. Now 2 is actually less than 5. Now it goes to the do. You can see the difference, right? And then it goes to the do and say is 2 mod 2 equal to 0. Now 2 mod 2 is actually 0, and 0 equal to 0 is 0 is equal to 0. Then that is only when it will now print. That's only when it will now print. It will print 2. Print 2 is an even number, right? Remember that because we have removed this first print, which is causing confusion here, right? That first print was causing confusion here, so it will only print out 1, this, right? So 0 is an even number, I equals 1, and then it prints 2. As I keeps on doing it until it does this answer. So let's run this again. Now you can see, right? So 0 is an even number, 2 is an even number, 4 is an even number, because the print we put here at first was one causing confusion. That's why. So even if it's not an even number, it's just printing it, because when the I is less than this, it should print out that first statement first. Now because we're trying to avoid that, remove that, and then it runs well. Now you can see you can actually write a while loop like this, or do while loop, or you can, it depends on one you prefer. But just understand how this tool works, right? How this works is, it first of all execute this, assuming that I is 1. Right, it first of all executes what is in the do here, and then before it checks the decision, the repetitive decision here. So when this one is false, then that is only when the iteration stops. Right, so that is how it works. Right, so that is, just be familiar with this. It's very easy to understand. Now let's look at some other examples, and let's look at the for loop. Now, the for loop is used when the number of iterations is known, right? The for loop is used when the number of iteration is known, right? So the for loop actually doesn't work like the while loop. It's used when the number of iterations is known. Let me give an example. Now let's look at example 12. Example 12. Let's see. Let's include stdioh. Then this our main method. So let me try to do a simple loop here, right? So I'll have my n. So n is just like my length here, right? But later when we're working on an array in our next video, we're going to be doing that, right? So next video we're going to be looking at arrays, right? And then look at module functions, right? That's when I'll show more examples on that. Now let's look at int n equal to 5, then int I is equal to 0, which is variable in 0. Now let's look at the whole loop for okay, let me put it here. I thought I'm still using while loop. So let me put it here. So int n equal to 5 for int I equals 0. Now if the I is less than the n, right, then what happens? I plus plus. Alright, I plus plus. Or let's try to do something. I plus 1. Right, so let's loop this. If this is this, and if this is true, then print I. Then we're returning 0. So let's try to run this. Just to see this example 12, yeah, this example 12. Let's see. Then this is the output. Example 12.exe. Then example 12.exe. So it's actually showing 0, 1, 2, 3, 4. So this is another way I equals to I plus 1, or we can just increment I by doing I plus plus, right? Now let's explain. Let's try to see how compare execute this instruction. So if we check the PowerPoint slide again, we see that the for loop is used when the number of iterations is known. I can see the number of iterations here is actually 5 because we are looping through, right? So let's look at this first. Now we say our I is 0, right? Our I is equal to 0. Get it? Our I is holding 0, and we are saying I is less than n. I is less than n and our n is 5. So since I is less than n, so I goes 5 times, which I equal to 0, starting from this I equal to 0, right? So I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4. Let's count it: 1, 2, 3, 4, 5, right? And then when I equal to 0, what happens? So when I equal to 0, prints I. So it will print what? 0, right? So when I equal to 1, what happens? It print 1. When I equal to 2, what happens? It print 2. When I equal to 3, what happens? It print 3 because I equal to 3. So when I equal to 4, it print 4. Right? So assuming we have I is equal to less than 5, n, right? Less than n. Now, what happens? Now, you can see we have 5 here, right? So 4 is actually, when I equal to 4, so our n is actually 5, right? 1, 2, 3, 4, 5. So when I equal to 4, so 4 is less than or equal to 4, right? So it will keep on incrementing I. So just work like the loop. Now, what about I equal to 5? Right? So 5 is equal to 5. 5 is actually equal to 5. Now, since 5 is actually equal to 5, and it will print to print 5. Right? To print 5. So if we run this, so this is 0, 1, 2, 3, 4, 5. Right? So you have to be very careful. So it works like the while loop. So if you don't want to understand it this way, the easy way to understand this, you can easily think of how the while loop works. Now it said I is equal to 0. So get it? You can do it like this. Now when I is equal to 0, what happens? Now when I is equal to 0 is 0 less than our n is 5, right? Is 0 less than 5 or less than or equal to 5? Now 0 is less than or equal to 5, so this is true, right? So since this is true, it will increment I. It will increment I, right? It will increment I, so our I becomes what? Our I becomes 0 plus 1, which is 1. And it comes here again, it comes in the next line here, and it will print 0. Remember, it will print, since this is less than this, right? It will print this 0 here. Let's just put it here. It will print 0 and then increment I. So that is what this means, right? So that is how you keep on doing it. In case you don't understand it this way, that is how you keep on doing it like this. So when I equal to 1, so it's 1 less than or equal to 5. So since less than or equal to 5, so it will print 1 and then increment this by 2. So now the same thing here. I is equal, now I is equal to 2. So there's 2 less than or equal to 2. Now since less than or equal to 0, print 2 and then increment this. Then comes here. So I becomes 3. So it's 3 less than or equal to 5. So since 3 is less than 5, so it prints what? It prints 3 and increments I, which I becomes 4. Now it comes here, I is equal to 4. Now since this our 4 is less than 5, so you print 4. You print 4 and then increment I, which our I becomes what? 5. So it's I equal to 5. So since 5 is less than or equal to 5, then you print 5 and then increments I, our I becomes 6. Then it comes here again, is I equal to 0, so I equal to 6, so it is 6 less than or equal to 5. Now since 6 is not less than 5 and 6 is not equal to 5, that is where the iteration stops. The for loop iteration stops. Right? So that is how it works. So I hope you understand it, right? So you can help you to easily learn. If you don't understand that way, I think this way is far better, so that you can be able to understand how this works. Now let's give another example here, right? Now if I have okay, let me do that in example 13, right? So we have understood this. Let's look at example 13. Example 13, let's see. So let me just copy what is example 12 so I can modify this. So So this is example 12. So this is example 13. Okay. So after this example, I'll be stopping this video. In the next video, we're going to be looking at netted loop, and I'm going to be looking at arrays. So we can work with arrays, right? For for loops, nested loop, and also for while loops. We're going to be solving some problems there, right? So let's look at this. We want to do the same thing where we did it, where we're trying to get the even number between 0 to 5, 0 and 5. Sorry. Then let's do this. So for I this now, if I module n, sorry, if I module 2 is equal to 0, now what happens? So it prints f, this in d, then let's do it. Go to the next line. So let's do it. It goes to the next line here, and then it will print I. Right? So okay. So I think that's all. So if there's this, then I think there's all. So let's try to do this together. So when I is equal to this, then if 0 is less than 5, now it will not print this, rather it will go to decision here. Now is 0 modulo 2 equal to 0? Now 0 modulo 2 is actually 0, so 0 equal to 0 is true, then that is when we're going to print 0. Then it comes here, so into increment I, our I is 1. So it comes here, our I is now 1, so it's 1 less than equal to 5, yes, right? So now it comes to this place here, 1 modulo 2, 1 modulus 2 is actually 1, so nothing happens, so to print out nothing. Right, so it will print out no, and then it will increment I. So that's how it keeps on doing this, right? In this it will print 2, in this one here it will be null, it will increment, in this one here it will print 4, in this it will be null, and increment I, and then the iteration stops. So what's this part? This instruction will print to 0, 2, and 4. So let's find out. So if we example 13, so we have gcc example 13 dot c output example 13 dot exe example 13 dot exe, right? So 0 2 4, right? So that is how it works. So you can see you choose between the while loop and the for loop. Which one do you want? Which one is being simpler? So tell me on the, which one is simpler. But tell me on the comment section. I'm always here to explain how it works and how computer processes the instructions. So thank you and God bless.